Problem 24 asks which of the following species can be Bronsted-Lowry bases. So very similar to number 21 that we just did. We're given 6 formulas again. We know that a Bronsted base, this time, is a proton acceptor in a neutralization reaction. So if you have a neutralization reaction, the formula or the species that is accepting a proton is the Bronsted base. Part of the criteria for somebody to accept a proton is for it to have a lone pair of electrons. The first one, yes, chloride ion is a Bronsted base. This is the chloride ion. And we can see how it works in a neutralization reaction. If you put chloride ion in contact with hydrobromic acid, that was one of the Bronsted acids in problem 21, in fact the first one. So if you put chloride in contact with hydrobromic acid and see what they do, the acid donates the proton and the base accepts the proton. So you'll see the chloride accepting the proton, and so the proton goes over to the chloride and you're left with HCl, and then bromide is left behind. If you draw the Lewis dot structure of chloride, you can see chloride has, the ion has 4 lone pairs of electrons around it, and it's negatively charged. So here's the Lewis dot structure of Hbr. So what happens is one of these lone pairs on the chloride form a bond with the hydrogen, and the bond that hydrogen already has goes back to the bromine. And so here are the Lewis structures that you're left with. Now chlorine has a bond with the hydrogen, and bromide has 4 lone pairs of electrons and then minus charge. BH3, no, this is not a Bronsted base. Draw the Lewis structure for BH3. You'll see there are no lone pairs of electrons that it can even form a bond with hydrogen. The third one, yes, water is a Bronsted base, or it can be a Bronsted base. Here's water, and you can see that it has 2 lone pairs of electrons, and either one of these can attach to an H+ ion. So if it did attach to an H+ ion here, I'll show you what happens. So here's an H+, and if you have these attaching to H+, then you'll be left with H, O, H, H. You still got one of those lone pairs, but now it has a plus charge, and that's your hydronium ion. So that plus is kind of sloppy here. Plus charge. So that's your H3O+. So for all of these, perhaps the ones that, perhaps the ones that are Bronsted bases, you could think, well, what does it turn into after it gobbles up a proton? So after this grabs a proton, it becomes H3O+. After this grabs a proton, it becomes HCl. What about the next ones? Okay, sodium ion. This is not a Bronsted base. There are no lone pairs of electrons. The next 2 are calcium hydroxide. Calcium hydroxide. This is an ionic compound, by the way. And so you got different ions. You got the calcium +2 ion, and you got your 2 hydroxide minus ions. Let me blow these up a little bit. Your 2 hydroxide minus ions. So either one of these hydroxide ions could grab a proton. So what do you think it would turn into? Suppose the one on the top grabs a proton. It accepts a proton from some acid in a neutralization reaction, what do you think? So that these lone pairs maybe form a bond with that proton. What would that turn into? Just these guys. Okay, forget about the other two for a second. Just these guys. Well, if you guessed water, you are correct. So water is the conjugate acid of hydroxide. The last one is the formate ion. Formate ion. Now, formate is very closely related to formic acid that we saw in number 21. Here's formic acid. Formic acid. Now, this is an acid. Up here, it has the ability to lose or to donate a proton in a reaction. Well, if it donates this proton, if another base comes by and grabs this proton, you would be left with the formate, which is that right there. Okay, so this is actually the conjugate base of formic acid. And imagine this formate ion sees a proton and it grabs onto it. What do you think it would turn into? Well, it'll turn into formic acid. Let me just copy and paste that. So where's that formic acid? Here it is. So it would turn into that. Okay. So formic acid is the conjugate acid of that base. So there you go. 4 Bronsted bases, 2 of them are not.